Here's the main thing. I want you to look at the disposition of endothelial cells and smooth muscles. Okay, here they are. There is a receptor here that can be, and this is a G protein coupled receptor, a different type of G protein coupled receptor. It's actually called muscarinic cholinergic receptor. It can be activated by acetylcholine. It uses GQ to activate phospholipase C, producing IP3 in the endothelial cell. IP3 causes calcium to be released. Calcium binds to this protein called calmodulin. Calmodulin then in turn activates the enzyme that we just talked about that produces nitric oxide. So I want you, before I continue, I want you to think, in the endothelial cell, we have produced a number of second messengers. IP3, calcium, and then a new one here. This is a gas, by the way. Nitric oxide is a gas, so it has permeability, easily diffusible between tissues. Nitric oxide is produced as a consequence of activating the enzyme that makes it. Now, nitric oxide diffuses into smooth muscle cells, activates the enzyme, the soluble enzyme, the guanylyl cyclase I mentioned to you before, producing cyclic GMP. Where? In the smooth muscle. So although this is a second messenger, goes here, activates guanylyl cyclase, producing another second messenger in the smooth muscle. This is the second messenger in the smooth muscle that promotes phosphorylation of different proteins in the muscle, causing smooth muscle relaxation by activating a protein kinase G. So I want you to, the reason I bring this up is I want you to appreciate that you can have different tissues producing different second messengers, but in this case, we have the direct second messenger responsible for smooth muscle relaxation is cyclic GMP, because it's produced in the muscle. And that's what happens first, smooth muscle relaxation. However, the way this is produced is dependent on what happens in the endothelial cells. The second messengers produced in the endothelial cells. Okay?
If you like this video, please subscribe. Thank you.